Yo, it's your boy Talanjum in the house, even though I don't need an introduction. So my time is up, huh?
Let's roll.
And your time is now. Wah. Abbe John Cena ke chode. Listen up. Joke on the beat. तूने बोला कि मैं मम्मी डैडी मेरे जैसे रैपर के लिए तू नेवर रेडी मैं तो संकी मेंटल 24 घंटे एवर रेडी पंजाबी पुत पंजाबी माँ पंजाबी डैडी ए तू मिक्स ब्रीड ये मैं नहीं तेरा ट्विटर बोले तू मेरी शक्ल देखे सुबह जब तू ट्विटर खोले ट्रिगर फिंगर्स टर्न टू ट्विटर फिंगर्स गलत बात आई वांट से मदरफक यू I'd rather से मादरजात समझते सब लेकिन बनते हैं ये ना समझ जो समझ के भी ना समझे समझो के वो ना समझ हने हने वहाँ हने काले नहीं काले बने तेरे जैसे चुतू रैपर मेरे आगे बेचे चने तू पीता है चरस ओके आजा मन चीज में लन खा तेरे वजन से ज्यादा मैं पी के बैठा हुआ चरस तभी 2 महीना रिहैब में बंद था मेरी गैर मौजूदगी में तुमने उखाड़ा क्या घंटा ठंडा हो ठंडा तेरे जैसे बहुत आए बहुत गए कोई नई बात नहीं मेरे फेम में किसी जुने जो का हाथ नहीं समझ गई पब्लिक तो जानती है पब्लिक समझदार है नशे का मरीज था पर अब सोचे बहाल है यूनस ने गाड़ा मलिक ने उखाड़ा मेरे हाथों तुम्हें जो पड़े वो चंदे की मार है गाड़ने का टाइम है बिना ऐलान घुस के फाड़ने का टाइम है कायम है जोर मेरा कायम है रैप है सारा तेरा लेकिन कम उसमें राइम है ये अबे तेरे को बोला तू भाई है कोई काम हो तो बोल देना टेंशन नहीं है तू कह रहा था कि तेरे पास पैसा नहीं है और मैंने समझाया था कि बेटा हसल यही है मैंने कब बोला कि मैं गोट हूँ नहीं मैंने नहीं बोला कि मैं गॉड हूँ तूने सिर्फ बड़ी लकड़ियां ही ली हैं अब तक आँख खोल मैं लोहे का रॉड हूँ अब घुसेगा पूरा तो फिर तकलीफ तो हुई होगी ब्रश खोलूंगा और बेटा आगे तेरी ठुई होगी और अपना वक्त तुझ पे जाया नहीं करूंगा इतना बुरा टाइम नहीं आया तुझसे चलूंगा हाथ बांध these gang signs don't mean shit तू कोई गैंग वॉर नहीं you ain't nothing but a bitch LUG ने उंगल की और मैंने उनकी ले ली ये हिजड़ों की फौज कभी निकले ना अकेली तेरे इलाके के मुजरिम है मेरे बेली तेरे जैसे चुतुओं को we be popping on the daily we be popping on the daily yeah अभी खत्म नहीं हुआ आगे सुन ये जो के बोला था कि बस कर छोड़ दे मत कर सबको पता है तू इनसे बेहतर लेकिन अक्सर मेरी अना बोलती है और वो तभी बोलती है जब मैं होता हक पर अबे मैं तब से कर रहा जब इधर कोई होता नहीं था बट
We must work together.
वो भी प्लांट एटलीस्ट
Planted. Bomb has been planted. dance on your grave. Let's go. Grenade! Grenade out! Grenade! Throw in the flashbang! Whoa! Smoke! Throwing fire! Flashbang! Counter-terrorists win. Let's go, my brother. I'm throwing the flashbang. I'm throwing fire. Let's throw.
The important is your code good? We care about excellent code. We don't care who you are. Like maybe you're a dog. I don't care, right? I don't care where you come from. I need to look at your code. Oh yeah, but I'm engineer at this very large company in Italy, in Germany, in the US. We don't care. We care about the quality of your code because this is what defines our community. And which means that we have a lot of people who contribute who are some very different backgrounds and very introverts, sure, but that's okay, right?
FFmpeg is probably one of the biggest CPU users in the world. Everything we've just said in the past couple of minutes, every sentence is someone's lifetime's work. There are books about every sentence. So the level of complexity in many cases is inordinate.
FFmpeg has 100,000 lines of assembly for all the codecs.
All codecs.
And just this one has 240,000. Every cycle matters. We are talking about probably 3 billion devices which are going to decode video non-stop because, for example, 30% of the video from Netflix are now in everyone, 50% of YouTube.
This is what peak video codec should look like. 79.9% assembly, 19.6% C, and 0.5% other.
And what's incredible is with those tweets, which is factual, people get crazy.
For the last 2 years, they go crazy. No, Intrinsics is fine. The compiler.
You can optimize your compiler, auto-vectorization, it's your fault, you don't understand. And we've tried that forever, right?
For 2 years, and 2 years later, showing hundreds of examples of handwritten assembly. No, you're doing it wrong. The compiler can do this.
The intelligence agencies tried to say, can you put a backdoor in VLC?
Yes, 2 of them.
What do you say?
No. Well, I was a lot less polite.
Basically saying hell no.
Like if we had to compromise our software, we would shut it down. This is clear.
Any tweets, Karen, you regret?
Tweets of regret.
Or is it like that? Well, how's the French song go? Regret nothing?
Don't regret.
Anything.
No, it's because regrets are a tax on your mind.
The following is a conversation all about FFmpeg and VLC with Jean-Baptiste Kempf and Kieran Cunha. FFmpeg is an open source software system that is the invisible backbone behind YouTube, Netflix, Chrome, VLC, Discord, and basically every platform that touches video or audio on the internet. It can decode, encode, transcode, stream, and play almost any video or audio format ever created. To me, it is one of the most incredible software systems ever developed, and it's all done by volunteers. VLC is also a legendary piece of software. It is an open source media player that plays basically anything you throw at it, any format, any platform, no ads, no tracking. It has been downloaded over 6 billion times, and again, for me, it has been one of my favorite pieces of software ever, with the most legendary logo, which I, of course, had to honor in this conversation by wearing the VLC traffic cone hat the whole time. So again, above all else, thank you to the incredible volunteer engineers who put their heart and soul into this code that has been used and loved by billions of people. Thank you. And about the 2 great engineers and human beings I'm talking to in this episode, Jean-Baptiste is the president of Videoland and is a key figure behind VLC and FFmpeg. Kieran is a longtime codec engineer, FFmpeg contributor, and the man behind the now infamous FFmpeg account on Twitter, X, that I recommend everybody follow for the memes and for the unapologetic celebration of open source and great low-level software engineering. Let me also say that it's inspiring and humbling that so much of modern civilization rests on software built by people who are not chasing fame or money, but are obsessed with the craft of engineering. We live in a world where billions of people consume video every day without ever thinking about the invisible machinery underneath it. But that machinery matters. Open source infrastructure matters. It is one of the great examples of human beings quietly collaborating across borders to build something useful, durable, and elegant for the rest of us. And so, this conversation is not just about codecs and media pipelines. It is also about the deeper spirit of engineering and generosity that makes projects like FFmpeg possible. Again, I can never say it enough. Thank you. This is the Lex Friedman Podcast. To support it, please check out our sponsors in the description, where you can also find links to contact me, ask questions, give feedback, and so on. And now, dear friends, here's Jean-Baptiste Kempf and Kieran Cunha. So the legend goes VLC can open everything. What's the weirdest thing that you know that it can open?
You know, there is a ton of people who are using VLC to record VHS videos, right? Like, it's just like you plug it with a capture card and you can basically record VHS video.
Well, how does that work?
basically it's those type of capture card where you can put a Piritel in or RGA, and you put that, and actually VLC can play those type of cards, and there is a module which allows to control directly those VCR camcorders. We support DVD audios lately, right? We spent the summer working on DVD audio support, and like there is no one's making any DVD audio support. There is a custom encryption schemes.
What about Lucasfilm?
Oh yeah, and there is of course all the weird codecs game codecs supported by FFmpeg.
The one Star Wars video game, the first 10-second opening sequence, someone has gone and implemented that and make sure that's bit exact on one disc that existed at one time of one little sequence in the game.
And then, funnily, there was at one Videoland conference, we made a competition to make the weirdest and most horrible file ever and see if VLC could play it.
What did it end up being? What's the file?
It was an MKV file made by Derek, which each of the frame was changing resolution, aspect ratio, rotation, and it was like...
Did it work?
Yes. And there was another one where the whole video was actually animated subtitles, right? SSA, right? So this one was, and so each frame was a black frame, but on top of that there was a subtitle that was animated for each frame.
There was a file that's a valid zip and a valid MP3 at the same time, or something like that. So
yeah, we made a competition of stupid files,
and it worked. It opened all of the stupid files.
Yes.
By the way, for people who are not familiar, I am wearing a hat. Would it be fair to say this is the best, worst logo of all time, the cone?
Yeah, by far, right? The logo of VLC is so iconic, right? Like, we are a team with a small number of people, and the icon is known everywhere. I go to middle of nowhere in India or in China, people know the cone, right? And 25% of the website traffic that comes to our main website is cone player, right? So many people don't know VLC, right? They know the cone player.
That's the thing that Google for is cone player.
Yeah, they go on Google and they put cone player and they download VLC, right? So that's iconic. And once we tried to change it as a joke, right? We said it was going to be a type of caterpillar construction, and we said that during April 1st. And we had around 10,000 emails saying, no, don't change the logo and so on, right? So it's so iconic, right? It's so distinctive, right? If you want to do a video player, you're going to put a play button on a TV, right? And that's a YouTube logo, right? It's an original. This one is orange, right?
Yeah.
Very bright, and it's weird.
And it's ridiculous, and it's absurd, and it's hilarious. It becomes meme, and meme becomes culture.
And you keep it, and you know about it, and you know that in 20 years, like, you still going to have the cones, and remember, oh yeah, that was a video player.
Yeah, and we'll talk about, the mission of FFmpeg being a kind of the archival aspect of it. So you can think about 1,000 years from now, we'll have all of these videos that only VLC can open. Human civilization has already destroyed itself multiple times, and the only thing that will remain is this, like, the cockroaches will be crawling around, and it'll be the VLC logo with some of the archival footage the VLC can open. And the aliens will show up, and they'll press play, and they'll get to see all
really hope so, right? But there is also so many memes where people say, well, I'm sure I can put a pancake inside my DVD drive and VLC will play it.
Can they?
No, we tried. It doesn't. But we actually have a video of us trying that. Didn't work.
A codec for physical reality? I don't know what that would even look like.
There was a guy who did that, right? He printed a small cone, right? Like the ones we distribute as goodies. And inside he put an RFID chip, which was his way of playing a movie, right? And so he put this on the RFID player, and when he put that, it was playing like the last Star Wars and so on. So instead of having like DVD boxes, he had like VLC cones all around, and he plugged that, and there was like physical effects.
So the thing that we're talking about is everything around video codecs, video encoding, video decoding, video streaming, video player client that I'm wearing on my head, the entire ecosystem enabling free media. We'll talk about FFmpeg, we'll talk about Videoland, VLC, and all the other incredible video technology that is used probably by billions of people. So, JB, you're the lead developer behind the legendary VLC player. Kieran, amongst many other things, you're lead developer behind the legendary FFmpeg handle on Twitter. And both of you have spicy opinions, I would say. So today we want to talk about FFmpeg and VLC. For context, for people who are not aware, and I'm sure Kieran, basically everybody listening to this have used these two technologies probably regularly without knowing it. So FFmpeg underlies basically most video on the internet, including YouTube, Netflix, Chrome, Firefox, of course, VLC, and countless other video platforms. It is estimated that over 90% of video processing workflows online and offline involve FFmpeg. VLC has been downloaded at least 6.5 billion times. But likely that number, because it's impossible to really count the number, is much higher than that. Virtually any operating system supports virtually any media format. The limitation being it can't open pancakes. So, can we just lay out some of the basics to help people understand what's involved in all of this? So when we press play on a video player like VLC, what happens? How does it go from the file or the stream to the pixels on the screen and the sound on the speaker? What are the big stages to be aware of?
So there are several stages, right? The first stage is to get from an address, right, which is like a type of URL, to give you a byte of streams, right? So this would be, for example, HTTP, file, DVD, right? You give the path to the media and gives you a stream of data.
The stream needs to be cut up by what's known as the container, the demultiplexer, or demux. We'll try and keep the jargon light throughout this, but it needs to go and start demarcating video and audio frames. So it just gets data from the operating system, blocks at a time, and needs to start cutting these frames up into compressed data. It then needs to start doing simple parsing of the video frames, mainly to figure out whether that codec is GPU decodable or needs to fall back to software. We're very sort of used to assuming the GPU will play all of these things, there'll be hardware acceleration. I think it's up to 45% of files are not GPU decodable. So these need to be probed, they need to be detected. There can be variants of a given codec, some of which are decodable on the GPU. Different vendors of GPU might have different capabilities. So those need to be detected. So if it's GPU capable, you pass it through to the GPU black box. So now if there's a software fallback, that means in the beginning is to first do de-entropy coding. So removing the mathematical coding of the bit stream. So this uses capabilities such as Huffman coding or arithmetic coding to actually decompress the mathematical layer of the bit stream. We then need to start reading the syntax elements for intra-prediction. So intra-prediction are like still images of the video, so your iframes. So this works and operates in the spatial domain. So you do your intra-prediction in the spatial domain, you have a residual because your prediction isn't quite matching that of reality. So you've made a prediction, but then there's a little bit left, and that's what's known as the residual. This is stored in the frequency domain, and these are quantized to decompand their space. We then need to do the inverse transform to bring them back to the spatial domain and apply these residuals.
So a lot of the process of the decoding is this thing is compressed.
Yes.
And you have to predict the highest quality thing that's supposed to go there. iframe is the best representation you have spatially.
Yes.
And then there's a lot of temporal compression that can happen depending on the codec. And then you're predicting what the reality that was captured in this rawest form.
Yeah, because what people don't realize is that the compression on video and audio is 100 times, right? Like people don't realize how compressed we do, right? For audio, you compress by, when you go from normal audio to MP3, you compress by 10 times, right? When you move to video, you need 100 times, 200 times, right? So you need to remove all the details, but that you don't care about, because all the compressions that we do, and that's very important, people forget about that, is to be viewed by humans, right? So all the codecs for audio mimic basically how your ear works, right? And a lot of things about like the response on the ear, and same for your eyes, right? And so for example, on video, we don't work on RGB, right? Everyone expects to work in RGB. We don't, right? We move to YUV, which is basically, one is luminance, brightness, and the other are colors. And this matches your eyes, where inside your eyes you have the cones and the buttons, right? With some of them look on brightness and more on the other on colors, right? So we need to compress a lot, and so we need to degrade. But in order to degrade, we need to match the human perception. And this is why it's so difficult. And then we need to use the maximum power, mathematical power, very complex technologies. We move to the frequency domain, as Kieran said. We do a ton of dequantizing, and in order to get the best compression, but it still looks good.
You're trying to compress in order to maximize the highest quality thing for human perception.
That is correct. And that is correct. And this is very important, right? Compression is not like a zip, right? A zip, you have data in, you get data out, right? And you try with all the zip compression to arrive with the limit. Here, we are degrading the signal, right? And so we need to degrade both the audio and the video signal in the best way possible. And we can do that, but it involves first a lot of theoretical knowledge about how it works, the AI works, but a lot of mathematical change, a lot of mathematical tricks, right? For example, when you move to RGB and you go to YUV, for example, what we do very often is that we scale down the resolution of the color compared to the brightness. And most of the time, and just this without compression, it divides the size by 2, but most people don't see it, right? And so on, right? And then you go to very complex mathematical change. So, of course, Fourier transform, which de facto are not Fourier transform. They are like discrete cosinus transform, but that's the same idea. So, frequency domain. We split the video by blocks, right? So that's why when it's wrongly decoded, you see those blocks, and badly encoded, you see those blocks, and so on, to arrive to compression states that are insanely high, right? And each generation of the codec is like 30% less for the same quality, right? And this requires amount of power, of computational power that are huge.
No, but you should elaborate. It's 30% better, but an order of magnitude, perhaps even 2 orders of magnitude more compression power. That's the big difference.
What do you mean by compression power?
Sorry, CPU power to achieve that level of compression.
Oh, yeah. So and you have to be able to leverage the CPU and sometimes GPU, like you mentioned. And then we should mention that a lot of this programming is done at the lowest possible stack, whether it's C, and of course, as the legendary Twitter handle re-emphasizes over and over, a lot of assembly.
So what happens is globally is that you have an address, right, which gives you, with the operating system, a stream of bytes, a stream of data, right? And this is the first step. And the second step arises with demuxing, where you're going to separate audio, video, subtitle in type of different tracks. And then on each of those tracks, you're going to decompress them, decode them, either audio with an audio codec, video to video codec, and subtitle to a subtitle codec. And once you've decompressed those type of things, you have raw images, and then you're going to talk with your graphic card in your screen and display that. And same for the audio, you're going to talk to your audio card, which then is going to go in analog to your audio speakers.
And everything we've just said in the past couple of minutes, every sentence is someone's lifetime's work. There are books about every sentence. So the level of complexity, in many cases, is inordinate. You know, it's every sentence has thousands of people working on this in the industry as a whole. Books written about it. So there's a lot of detail, there's a lot of subtleties, there's a lot of both academic and practical realities, both of which matter.
We mentioned codecs, but I don't think you mentioned containers. So what's the actual containers for some of the stuff we're talking about, so people are familiar with it? MP4, MOV, MKV. So anyway, what are containers versus the thing that goes inside?
So the container is what we call also the muxer, right? When I say demuxing, it means decontainizing, right? So actually, if you look, mux means multiplexer and demultiplexer, right? Mux and demux are those. And same codec is actually coder, decoder, right? So containers are this collection of multiple tracks, right? So it's what normal people call the file format, but it's a bit more subtle than that. But the most known one, of course, is MP4. But when I started, it was AVI, right? AVI was the video format from Microsoft, and MOV, which became MP4, was a format from Apple. In the open source community, one of the person that is still active on Videolan is called Steve Lorm, and started this Matroska format, which is like a bit more complex and more feature proof. And there are so many others.
So, I mean, it's a pretty common thing, and maybe it'll even happen in this conversation, that people confuse container and the codec, right? So confuse MP4 and H.264, for example. Is that a horrible violation?
No, it's not, because technically the name of H.264 is MPEG-4 part 10, because MPEG-4 is actually a meta specification which has several things in it, right? There is the part 2, so there is like audio codecs, right? AAC is the factor with MP4 audio something. There is actually several video codecs, right, inside the MPEG-4 specification. One of them is MPEG-4 part 10, called also AVC, called also H.264, right? So it's completely the fault of the industry to make things difficult to understand. So that's very difficult, so that people then don't understand why sometimes you talk about MPEG-4 part 10 where you mean H.264 and why it's not MP4.
So you can technically shove in all kinds of different codecs inside containers, and horribly so.
But broadly speaking, though, MP4 is understood to generally be H.264 plus AAC audio. 99% of the time, that's that, and that. The rest are de minimis, the small effects, edge effects, really, compared to that. So it's not the end of the world. That there are people who do get annoyed by that. But also in reality, something like VLC, just to point out, the file may say .mp4, but it may be something completely different. And that's one of the challenges both FFmpeg and VLC have, is the real world is a completely different place to a 3-letter file format.
And this is very important to say, right? Like, for example, in VLC and FFmpeg, we discard the file format, right? We look into the file to understand what's in it. Because so many people, like, they say, oh, it's a video, it must be MP4, but technically it's an MOV, or maybe it's a MKV, right? So we analyze in real time everything that we have, and we don't trust the format.
So what information does the fact that it's .mp4 give you?
It helps, right? It gives you a hint, right? Just like, oh, it's finished by .mp4. I will start first by probing it with the MP4 container demuxer to see, well, it should be that, but I don't trust it, and if I'm lost, I say, okay, maybe I'm going to try. So it bumps the priority of the module.
So how do you get to, just to take a bit of a tangent there, the dumb thing is, if you try the MP4, but it turns out it's a different codec than you would have expected, most players just break there.
Yes.
Yes.
So how do you not break? There's just philosophically, I'm sure there's a bunch of stumbling blocks along the way where it's easy to just break and stop, freak out. That's it. How does VLC not?
This is why VLC is popular. But the reason is because actually VLC is just a client of a streaming solution called Videolan from very long time ago, from the late 90s. And when you're playing video which are on UDP, right, in network, they might be damaged, right? So you don't trust your inputs. And this is very important into the security, is that you don't trust your inputs. So everything in VLC is prepared to work with broken files. Mm-hmm. And it's a philosophical idea from the beginning, and everything is engineered into that. And it's a culture, right? And so, for example, and VLC became very popular on that because a long time ago, when people were pirating content, which they do a lot less today.
And none of us ever have.
No, of course not. The metadata to play some files like AVI is at the end of the file, right? And when you're downloading, you don't have that, right? So VLC was just like, hey, this file is broken, but I'm still going to try to interpret it. And this was very useful.
We hinted at the awesomeness of the various different stages. We hinted at the awesomeness of codecs, the depth and the richness and the complexity of everything involved there. Let's just try to define, what is a video codec? What's involved there? What does it mean to compress something? You already started to hint at it, but can we elaborate a little bit more?
So there's a huge amount of redundancy in any video, both spatial and temporal. And the point of any video codec is to remove this redundant data, use mathematical properties as part of this reduction process. So more often than not, using several orders of magnitude more compute to compress, because that's more costly, versus both financially and in CPU resources, versus the decompression. So it's asymmetric in that respect. Often the case because compression is done once, but there could be lots of viewers of another file. So to take that information and compress it by 100x, 200x, removing redundant information and using mathematical properties to make that small, but also have properties such as error resilience. So as JB suggested, VLC in the beginning was used to play UDP network feeds, and UDP network feeds lose packets. And so some of the design goals of a codec is also to be recoverable. You need to actually be able to join a stream. It's not necessarily a file. You need to join, get on the decoding process, and start decoding.
And to give a more image to people who are not familiar, right? Like when you're going to see any type of movie, right? You're going to see the camera is going to pan, right? And travel. And you realize that, for example, all the background is the same for like a minute, right? Or 30 seconds, right? So you can reuse the cloud that you see on the background. You can reuse that from a frame to another, right? And so it's gets the more memory you have, the more power, the more comparisons you can make, right? And so the more compressed you can be. And most of the modern codecs are basically doing that.
So, just to make it even more explicit, what is video? Video is a bunch of pixels, often RGB. You have 3 values, and you have a grid of pixels, and you have, let's say, 24 or 30 or 60 frames a second, and you just have all these pixels repeating and showing different stuff 30 times a second. And so the question, philosophical, technical question is, how can I compress all of that, store all of that at 100x?
Or 1000x, right?
1000x.
The target is 1000x, right?
And the goal is, when you say redundancy, what is redundant meaning? Stuff at best that humans wouldn't notice if it was missing.
So, for example, you have a picture of a cloud, right? And from the next frame, there's still going to be the same cloud. So it's redundant. You could just put it once and not do it, right? Or you have a black background behind me, for example. The black is the same on the whole picture, right? So you can say, well, you know, in this picture, take the pixels that you have on the top left and the one on the top right. I'm not going to give the value. I'm just going to tell you it's the same at the top left. And then you can say for frame 1, reuse something from the previous frame or the previous frame, and so on, right? So you could basically, it's unlimited, but then it's limited in terms of memory or in terms of compute power. Because, for example, if you need to compare pixels on 200 frames in the past on 4K resolutions, it's a huge amount of compute.
And then when you're showing it, you have to do the decompress of all of that. So is it the codec has the encoding and the decoding is a coupled process that you're developing.
Exactly, right? And those are two different trade-offs, right? Are you going to compress more, but then it might be more difficult to decode? Are you going to make it a codec that is more complex to encode and easier to decode? Are you going to make a codec that is easier to encode because you need to be fast, but then the client side, the player is going to spend more time? That's why you have so many different type of codecs, is that it's not always easy. And to make it even more complex, modern codecs like AV1, AV2, or VVC are actually not codecs. They are a collection of tools, right? There are multiple tools, multiple codecs in the same codec to, depending on the image, get the more compression.
So just to elaborate, codecs like AV1, VVC have a wide audience. It could be a screen share content, it could be video, it could be animation. All of these require different coding tools. So what happens these days is a collection of tools are put in and called AV1 and called AV2, called VVC to allow for different use cases. So you may be on Zoom and sharing your PowerPoint, and then you need to show the audience a video. That codec needs to start changing its tool set depending on the content to compress in a different way.
And like you said, there's a bunch of incredible engineers behind each part of that, each part of the tools that make up AV1, for example.
Sure.
So we've kind of danced around it. We talked about VLC, the logo, the hat. Let's talk about FFmpeg. What is FFmpeg exactly?
FFmpeg is basically the low-level libraries for codec, so compressions and decompression, muxers and demuxers and filters. It's the core is this, and then you have a several tools which allow you to create a type of pipeline to process any type of video files. And it's used as a library absolutely inside everything from VLC to Chrome to your smart TVs to basically any video that you see online. You usually use FFmpeg, and FFmpeg in it has all those type of tools, and sometimes depend on other libraries like X264, libvpx, and others, right? So it's really now the de facto tool to process images.
From a philosophical level, I think it's incredible that your home videos, your grandmother's home videos, and trillion-dollar corporations effectively are on a level playing field using the same technology stack. It wouldn't be a surprise, you know, these big companies just have 3,000 line FFmpeg commands. There are some that use the API, but there are some that just have long command lines.
So yeah, there's a bunch of tools, like literally command line tool, FFmpeg, of course, FFprobe. There's libraries, libAV codec, libAV format, libAV filter. But the FFmpeg on the command line is like legendary. Because you can cut, there's so many parameters, you can customize everything to hell.
It's a language. It's an actual language.
An actual, yeah, you could think of it as a programming language.
Yeah, of course, I'm sure. Because so most of the people, they're going to take FFmpeg, file in, file out, and specify the format, right? But you can, we've seen thousands of characters, and we've seen also like people like doing programming generation of command lines to make FFmpeg. There is a ton of people who are using AI to generate command lines for FFmpeg because you have no idea what it is. But you can specify so many filters, right, on command line, right? So FFmpeg is this collection of toolbox for multimedia processing that everyone uses. And everyone that is watching your videos are also using, right? You're on YouTube. Well, it's FFmpeg on the client side. Well, your server side, on the server side, the client side is probably Chrome. Well, you're using FFmpeg also, and you're using OBS to record. Well, it's FFmpeg, right? You're using a ton of important like big box professional boxes. Well, it's very possible that inside some part of FFmpeg is running.
I mean, there's like so many, just to give people an idea. Like I use FFmpeg a lot on everything, just trivial stuff like take a video, add an intro video and an outro video, and fade one into the other, like what is it called, dip to black, like where it dips and then shows the next video, and does the same thing with audio. There's like a cross dissolve of the audio. It quiets the audio and makes it loud again. And then there's a bunch of stuff like showing the captions on screen, hard, like baking the captions in. You can customize the font. You can do all kinds of layering of audio and video. There's a million things, and of course, all of that works like magically with basically any codec. Like anything you could shove in on the audio and the video side, it works.
But it's like if you look at, for example, you can do things that you would do with Adobe After Effects in command line on FFmpeg, right? And it's very interesting because, for example, for images, there is not such tool. There is a few tools, but not with the breadth of FFmpeg.
So ImageMagick has a similar kind of
yes, but you will
spirit,
not do some filters, complex filters. You don't have the equivalent of Photoshop in command line, right? But for video, you have FFmpeg in command line.
Yeah, it's incredible. I mean, it's like it's an example of a thing when a bunch of great people get together and they get a vision and they stick by that vision for many years, which is incredible.
And the vision behind, and the same for VLC and FFmpeg, is that we make everything that is very complex easy to use for the normal people, for everyone, right? Our goal is to make something that is insanely complex technically and make it easy to use, right? And people, they use VLC, they drop a file, they don't realize how complex the file is, but they play it. Or people put any type of thing inside FFmpeg with complex filters, and it just works like magically, right? And people, and this is our mission, right? Make very complex things.
We wouldn't be here, and you wouldn't be here if this required, you know, a traditional television studio setup It's tools like FFmpeg that democratize this. The podcast and streaming revolution, the YouTube revolution, was caused. FFmpeg was a big player in that because it democratized this technology that was once in the 90s, for example, you needed equipment that cost hundreds of thousands of dollars to do compression. It was the size of a car, and now everybody has that at almost an exact level playing field. And that's something that's so remarkable.
It gave voice to a lot of people. And we just to clarify, we say you wouldn't be here, not the human, but the podcast.
The podcast, sorry, you as the,
I
sorry.
would still, VLC did not have anything to do on the biological level
But
creating
it's
me as a
like,
human.
You realize also everything moved from text to images and images to video, right? Look at social networks. Video is everywhere. It's the most powerful medium there is, right? And when you see shorts and in reels and in TikTok, right? It's amazingly powerful to give. Video is amazing for that, right? But the complexity is important.
This is what people don't realize. I mean, this is really, it gave power to the individual all across the world as real freedom. And I think, I can't believe it, but we still haven't mentioned the actual obvious thing for people who are not familiar, which it's open source. And there's a open source community of users and developers behind it. So it's a movement. So like, we'll talk in a bunch of different ways about the community behind it, but can you speak to the open source element? So when we say, what is FFmpeg? It's an open source project.
Yeah, so FFmpeg, VLC, X264, Videolan, everything we do is fully open source. And for the people who don't understand how open source is, my usual analogy is about a chocolate cheesecake, right? Usually when you want to buy your cheesecake, you go to a bakery, they give you the cheesecake. The other way of having a cheesecake is have your grandma give you a recipe of how to make that. When we do open source, we give you the chocolate cake and we give you the recipe to actually remake the same cake, but at the same time tell you how to build the oven and also how you're allowed to modify the recipe and resell it to someone else.
Yeah.
And this is because software is just a very long recipe of small instruction. Computers are not very clever. They go very, very fast. So a normal program has tens of billions of instruction instead of the tens when you have your chocolate recipe. So a lot of the software industry was about selling software, like where you just have like the final cheesecake. In open source, we give you everything. And that managed to get a lot of people work together, right? Because then you decide that you're going to make the best program, the best recipe for video, and you create communities. In FFmpeg, since the beginning of FFmpeg, probably 2,000 to 3,000 people have contributed from the beginning, right? And then it's exactly like the Linux kernel, right? The Linux kernel has probably 10,000 people contributing everywhere. And they get together, well, mostly online, right? So they virtually get together to create the best tool for something. And on FFmpeg and VLC, it's just like, well, this codec doesn't work. So I'm going to work on the codec and I'm going to add the support for this file inside FFmpeg so it will be beneficial to everyone. Because again, we work for the greater good. We work for everyone. And that is what open source is.
And we should mention, depending on the licensing, you could probably build $1 billion, maybe even $1 trillion company around as a rapper.
Well, yes.
People do.
People do, right? There was a lot of problems with mostly cloud providers who are basically running some open source tools in the cloud and just give you the API to access to that. And there was a lot of databases like Mongo or Elastic who changed their license in order to avoid those type of scenarios.
This is a question we get a lot in FFmpeg: is why don't you do that? And you can't. We have thousands of contributors, some of whom aren't even alive anymore. You would need all of their agreement to do that. And JB will go maybe a bit later and talk about how challenging that process was in VLC to do the relicensing.
The license is a social contract in terms of Rousseau de facto of the community. The community does not agree on much beside the license. People go around, discuss around, because of the license. And that also allows those license fork, right? Sometimes the community splits but it's possible because of the license and to merge back. And we've seen that so many times, right? GCC and and EGCC in the past. We have seen, for example, all the web browsers, right? They started as KHTML, which becomes WebKit, and then which becomes Blink, right? So open source license is like the core of the community, and people are coming from all around the world, very different type of religion, political borders. They work in the same way on a project to solve a specific problem. And the specific problem we're working on is to make multimedia easy for everyone.
Looking it up on Perplexity here, looking at the different open source licenses, most major open source licenses fall into two buckets: permissive, very few conditions, and copyleft, share alike requirements for derivatives. Below is a brief practical summary of the main ones you'll see in the wild: MIT license, BSD, ISC, Apache, GNU GPL, GNU AGPL. Where's LGPL? Yeah, LGPL. Let's see. There's the Mozilla public license. There's Eclipse public license. It goes on. There's a lot of variety. I think the really popular ones is MIT, GPL, LGPL,
And BSD.
BSD.
and BSD, Apache. Sometimes you
Apache
see
as well.
Apache.
And
unlicensed. That's an option. Attempts to dedicate code to the public domain with a fallback permissive license.
There are many licenses for many different things. What people don't understand that public domain is something that doesn't exist worldwide, right? So it's all the open source licensing use the copyright law, right? The international copyright law, in order to give rights on how you use the software or how you modify. It's de facto a copyright license contract that you give to the end user or to the developer. And so you have like the first one, which are basically very permissive, MIT, BSD. You give the code and basically you do whatever you want, right? You take it, you modify, you do what you want. And this is popular for JavaScript and the type of BSD operating system.
So some of them, one of the parameters is whether they require attribution, meaning if you use the code, you have to say.
Yes. So in those type of permissive license, some you need to say if you use it, which is called attribution, and some you don't. And then there is the other part of license, which are copyleft, where you need to give back to the community your modifications, and with different string attached. Some weak copyleft license, like the Mozilla public license, to some which are a bit stronger, like GPL, or even very strong, like AGPL. So all of those are different type of licensing that depends on what your goal are and how you want to structure your community, which is why I spoke about social contract, because this is very important to understand. FFmpeg and VLC are mostly GPL or LGPL. The Linux kernel is GPL, but Android is Apache. A ton of JavaScript framework that are using are mostly MIT. All the BSD kernels, OpenBSD, NetBSD, are of course BSD. And so it's philosophical change on how you want people to contribute back, basically.
So there's, I think you talked about that you've moved at one point from GPL to LGPL on certain parts of the project. What can you describe the difference between the two, and what does it take to move to, I guess, a more permissive? So that direction is more permissive. LGPL is more permissive than GPL.
Yeah, so you have to realize that you can always go from more permissive to less permissive, right? Because of course, those licenses are basically statement. So if you restrict, you can always restrict more, right? So in a GPL project, you can take MIT code, but you cannot do the opposite, right? Because they are more constrained to match. Indeed, in fact, I changed the core of libVLC, which is the engine of VLC, from GPL to LGPL. And there were two reasons to do that. The first one is that so people can use the VLC engine, libVLC, into third-party applications. So a lot of applications which are playing video on your phone or on your tablet are actually VLC engine in it, which is calling FFmpeg in it.
Yeah.
So that was one of the way to create one of the company I created, which is doing consulting and integration of those types of application, where you integrate VLC into third-party solutions, like inside game engines or stuff like that. With GPL, you couldn't do that because that means you needed to open source everything, and those are for a lot of like commercial companies who don't want that.
So you can create a company with LGPL. You can create a company around it. You
Yes.
can do a commercial thing. You don't have to open source it. So
Yeah.
that's a big, big leap.
So you could play video in your game.
Yes.
The problem is I'm a game developer, and I want to play some videos, and I don't want to be forced to open source the entire game just to play those videos. So that's where the consulting business, the libVLC LGPL, allows you to do that. The LGPL, the library GPL as it used to be known, allows you to do that.
And FFmpeg is exactly the same. LGPL forces you to give back what you change on this component, this
Yeah.
library, which is why it's library GPL. And so you can use FFmpeg as LGPL into like any type of application, even non-open source, but you need to give back the modification you did on FFmpeg. Same on libVLC.
Is it limiting from an open source perspective to go GPL? Because if your library, if your code is GPL, it means you're basically discouraging companies from building a business around
Yes.
it, right? Is that fair to say?
It depends on the company, but a company whose business model requires the application to be closed source, yes, it's limited. So that's why, for example, I moved to LGPL. The second reason is a bit more obscure, is that the terms of condition of the App Store, the Apple App Store for iOS, makes it very complex to have GPL application on it, while it's easier to have LGPL applications on it. So VLC on Windows and on Mac and on Linux is GPL. The core is LGPL, but on iOS, the iPhone version and the Apple TV version is a type of different license called the MPL. And yes, I went and changed the license, and it was a long story.
Yeah, so I think basically to change the license, you have to contact all the contributors.
Yes, it's very important to understand that open source projects are what we call in the US copyright law joint work, or in civil law collective works or collaborative works. Is that you work all together in terms of the same goal, and then it creates one software, which is one release. But the copyright is kept by all the individuals. Some open source projects don't do that, they force copyright assignment, but this is not what we do, we're communities. So everyone has basically copyright on what they changed. And this copyright stays even if at the end your contribution was deleted, because the new contribution was based on your previous one, right? So if you want to properly relicense, you need to find all the contributors, and at that time I had to contact more than 350 people, and sometimes, well, they're just an email, right? So you need to actually track down. I actually like traveled to some place to go somewhere that I was like sorry that I had found online to see to go to their job and say, well, you licensed that, do you want to change from GPL to LGPL? Most of the times they don't even care, they wanted to help VLC. But also it brought me to a very complex situation. I arrived to the work of a person who was a factory worker, and I said, well, I need you to sign that, because it was his son who died, who actually wrote the code, right? So I had to explain all those type of open source meaning, and no, I was not a company trying to rip out the 2 lines or 5 lines that guy did, but was useful, and the whole community agreed on that. And he had no idea I was a factory worker. And I was a lot younger, right? Like it was 14 years ago, and like I was almost in tears, right? It's very difficult, right? We are talking about lives of people, and he explaining, and we went to talk about the photo of this guy, right? So it's important to do it right and to do it correctly. But yes, that means tracking down everything, because every contribution works. There are some projects who don't respect that, and we do relicensing a bit like aggressively. But as I said, it destroyed the whole heart of the community, because we only agree on the license, so that's important.
I would emphasize the community is such a wide-ranging group of people. There's people in the Syrian war zone with electricity part-time. There's all people from all walks of life, rich, poor, young, old. So it's quite remarkable to get, a group of people aligned on something. And that's an achievement in itself.
Yeah, it's incredible, and a lot of them are introverts. So you coming to find them and getting them to answer an email, it might be quite difficult.
Most of us are introverts, right? You need to be more precise. You are extremely introverts, extremely introverts, and introverts, right?
Yeah.
It's just like a whole spectrum of different people. It doesn't matter. The important is your code good? Is your code great? Is your technology great? We care about excellent code. We don't care who you are. Sorry, it's just like we have no idea to check. We cannot check, right? Like maybe you're a dog. I don't care, right? I don't care where you come from. I need to look at your code. And this is important because people don't understand that and they come to the community and send them some patches and they get rejected and they don't like that because I mean, you're just like, sorry, it's not up to our standards. Oh yeah, but I'm engineer at this very large company in Italy, in Germany, in the US. We don't care. We care about the quality of your code because this is what defines our community. And which means that we have a lot of people who contribute who are some very different backgrounds and very introverts, sure, but that's okay, right?
So one of the legends of the community is, of course, Linus Torvalds, who created Linux and is a longtime maintainer of the Linux kernel. As the legend goes, he can be pretty harsh on this meritocratic process of reviewing the code and saying it's not good enough. Can you just speak to the legend of Linus Torvalds?
Linus is one of a kind, right? And I would even go and say that what he did on Git is more interesting than what he did on the Linux kernel. He's very harsh, but what people don't see is usually when he's harsh to, it's people who are maintainer of part of the kernel, right? So they know him, right? So he's not very harsh like that to everyone. The thing is, what he created in his room is basically powering every server online, right? Even at Microsoft Cloud called Azure, I'm quite sure 70-80% of the servers are running Linux. All your Android phones are running Linux. What he did with the power of open source, sure, is amazing. And yes, the quality of the Linux kernel is very high, and yes, it's difficult, but we cannot compromise on that. We cannot compromise on quality, because in the end, and you have to understand that, is the core community of VLC is 5 people. The core community of FFmpeg is 10 to 15. And we are the ones who are going to maintain your code, right? Because 1,000 contributors in the timeline and just 10 staying, it's 1% chance that someone comes and stays. 1%. So you will have change of job, change of wife, you have children, you have accident in life, you're going to change jobs, whatever. You're not going to come back. It's most likely. So we are the ones going to maintain your code. It needs to be maintainable. It needs to be excellent. And yes, sometimes that means that you need to rework your work because it was good, but it's not excellent. And we need excellence because we have very few to maintain something that is critical for the whole.
But we should also mention that there's some spiciness, some harshness to the language that's sometimes used when you're keeping this high bar of excellence. Is there something to say to that?
It's true, right?